Hey there, science fans! Have you ever wondered what makes up the air we breathe, the food we eat, or even our own bodies? The answer is chemistry. Chemistry is like a giant puzzle, helping us understand the amazing world around us. It's the study of matter and its properties, as well as how matter changes. From the smallest atom to the largest star, chemistry plays a vital role. Think about baking a cake. You combine ingredients like flour, sugar, and eggs. When you bake them in the oven, a chemical reaction occurs, transforming those ingredients into a delicious treat. That's chemistry in action. Chemistry is not just confined to the lab. It's happening all around us, all the time. It's in the vibrant colors of a sunset, the rust forming on a bike left out in the rain, and the process of photosynthesis that allows plants to convert sunlight into energy. Chemistry is essential for life itself, driving the complex processes within our bodies and the environment. So buckle up and get ready to explore the fascinating world of chemistry. Let's dive into the fundamental building blocks of matter: atoms and molecules. Imagine the tiniest thing you can possibly think of. That's an atom. Atoms are incredibly small particles that make up everything around us. They're like tiny Lego bricks, combining in different ways to create everything we see and touch. Atoms themselves are made up of even smaller particles called protons, neutrons, and electrons. Protons and neutrons hang out in the atom's center, called the nucleus, while electrons zip around the nucleus like super-fast race cars. Now, when these atoms join together, they form molecules. Think of molecules as two or more atoms holding hands. For example, water, which we all need to survive, is made up of two hydrogen atoms and one oxygen atom, forming the H2O molecule. Just like Lego bricks can be combined to create different structures, atoms combine in various ways to form an incredible diversity of molecules, each with its unique properties. Now that we know about atoms, let's talk about how scientists organize them. Enter the periodic table, a chemist's best friend. Imagine a giant chart that lists all the known elements in the universe, arranged by their atomic number, which is the number of protons in an atom's nucleus. This incredible tool helps us understand the relationships between different elements and predict their behavior. The periodic table is organized into rows called periods and columns called groups. Elements in the same group share similar chemical properties. For example, the far right column contains the noble gases, like helium and neon, which are known for their lack of reactivity. They're like the quiet kids in the back of the classroom, not really interacting with anyone else. On the other hand, elements in the same period have the same number of electron shells, which are like energy levels for electrons. The periodic table is a treasure trove of information, providing a roadmap to the elements and their unique characteristics. Hold on to your hats because things are about to get reactive. Chemical reactions are happening all around us, all the time. They involve the breaking and forming of chemical bonds, leading to the transformation of substances. Think about burning wood. The wood reacts with oxygen in the air, producing heat, light, smoke, and ash. The original substances, wood and oxygen, have been transformed into new substances with different properties. Chemical reactions can be classified into different types, such as synthesis, decomposition, and combustion. Synthesis reactions involve combining simpler substances to form more complex ones, like building a Lego tower. Decomposition reactions are the opposite, breaking down complex substances into simpler ones, like dismantling that Lego tower. Combustion reactions, like the burning wood example, involve a substance reacting rapidly with oxygen, releasing energy in the form of heat and light. Understanding chemical reactions is crucial for various fields, from developing new materials to understanding biological processes. Section 5. Holding it together. The power of chemical bonds. Atoms and molecules don't just float around randomly, they're held together by special forces called chemical bonds. These bonds are like tiny magnets, attracting atoms to each other and forming molecules. There are different types of chemical bonds, but the two main ones are ionic bonds and covalent bonds. Ionic bonds occur when one atom donates an electron to another atom, creating oppositely charged ions that attract each other. Think of it like a game of hot potato, where one person throws the potato or electron to another. Covalent bonds, on the other hand, involve atoms sharing electrons, like two people holding on to the same potato. These bonds determine the properties of molecules, For example, water molecules have strong covalent bonds, giving water its high boiling point. Chemical bonds are essential for life, holding together the molecules that make up our DNA, proteins, and all the other complex structures within us. Section 6. From solid to gas. Exploring states of matter. We encounter matter in different states every day: solid, liquid, and gas. These states depend on the arrangement and movement of the particles within the matter. In solids, particles are tightly packed and vibrate in place, giving solids a fixed shape and volume. Think of a brick. It holds its shape and doesn't suddenly spread out to fill a room. In liquids, particles are still close together but can move around more freely, allowing liquids to flow and take the shape of their container. Imagine pouring juice into a glass. The juice takes the shape of the glass but doesn't change its volume. In gases, particles are far apart and move around rapidly, filling any container they occupy. Think about blowing up a balloon. The air inside expands to fill the entire balloon. Changes in temperature and pressure can cause matter to transition between these states, like water freezing into ice or boiling into steam. Section 7. Chemistry in our world, everyday applications. Chemistry is not just something you learn about in a textbook. It's all around us, impacting our daily lives in countless ways. From the moment we wake up to the time we go to bed, we interact with products and processes that rely on chemistry. Think about the soap and shampoo we use to clean ourselves. They contain chemicals called surfactants that help remove dirt and oil. The clothes we wear are often made of synthetic fibers like polyester and nylon, which are products of chemical reactions. The food we eat is grown using fertilizers and protected from pests using pesticides, both developed through chemical research. Even the medicines we take to stay healthy are the result of years of chemical research and development. Chemistry plays a vital role in providing us with clean water, energy, and technological advancements that improve our quality of life. It's hard to imagine a world without chemistry. Section 8. Chemistry shaping the future. As we look to the future, chemistry will continue to play a crucial role in addressing global challenges and shaping our world. One major area of focus is developing sustainable energy solutions to combat climate change. Chemists are working on improving solar cells, developing new battery technologies, and exploring alternative fuels like hydrogen. Another important area is medicine and healthcare. Chemists are constantly developing new drugs and therapies to treat diseases, from cancer to Alzheimer's. Nanotechnology, which involves manipulating materials at the atomic and molecular level, holds immense potential for revolutionizing medicine, electronics, and other fields. Chemistry will also be essential for addressing food security, as the global population continues to grow. Chemists are working on developing genetically modified crops that are more resistant to pests and diseases, as well as improving fertilizers and irrigation techniques to increase crop yields. Section 9. Keep exploring. The adventure continues. Congratulations, science explorers! You've journeyed through the fascinating world of chemistry, from the tiniest atoms to the grand challenges facing our planet. But this is just the beginning. Chemistry is a vast and ever-evolving field, with endless opportunities for discovery and innovation. So keep asking questions, keep experimenting, and keep exploring the wonders of chemistry. Who knows what amazing discoveries you might make? Remember, science is not just about memorizing facts. It's about understanding the world around us and using that knowledge to make a difference. Now go out there and keep the spirit of scientific inquiry alive.